Good afternoon. Welcome to an in-person event, which is always exciting. Applause for the in-person event. So my name is Jason Delborn. I'm a professor in forestry and environmental resources and also the director of the Science, Technology, and Society program here at NC State. And I'm really happy to welcome you all to this event where we get to celebrate the work and book of Elizabeth Jones, Ancient DNA. So thank you for coming today. I just want to tell you a little bit about Elizabeth and also thank the organizing committee and tell you how the day will go. So Elizabeth is an alum of NC State. She did her undergraduate work in history and philosophy here on our campus. She specialized in the history of evolutionary theory with William Kimler, who's here in the audience, and studied dinosaur paleontology with Mary Schweitzer. Is Mary here? She's in Montana, so she's not here. So that's fine. Elizabeth then went on to get her master's in history and philosophy of science at Florida State University and earned her doctorate in science and technology studies at the University College London. So for those of you who are science, technology, and society students, here is a PhD in STS, in case you didn't believe they were possible. She is currently the coordinator of Cretaceous Creatures, which is a public science project in the Paleontology Research Lab at the North Carolina Museum of Nature and Science, and she is a postdoctoral researcher here at NC State. Throughout her career, Elizabeth has worked alongside scientists from paleontologists to geneticists, working in both the field and the lab. So this is really a fantastic time for us to hear from a scholar who works across the boundaries of natural science, physical science, and social science, and the humanities. And working across those boundaries is an especially wonderful challenge. And so we're really happy to have Elizabeth here today. I'd like to thank the folks who helped organize this event. So Karen Ciccone and Marion Fergola from the NC State Libraries were instrumental in putting this event together. So thank you. This event is also sponsored by our Science, Technology, and Society program, as well as the Genetic Engineering and Society Center and the Genetics and Genomics Academy. Martha Burford-Reiskind is part of the GGA. I'm part of the Genetic Engineering and Society Center and STS. And so we have quite a great group of campus organizations and people who've come together to sponsor this very interdisciplinary and fantastic book project. It's not, well, it's a book program more than a project. You've done the project. So without further ado, I'll invite Martha and Elizabeth to come up to the stage. What we'll do is Martha is going to lead a discussion with Elizabeth after Elizabeth makes her presentation about the book. And we will have a chance for audience questions in the last 10 minutes or so of the program. For logistical reasons, I'll ask that you raise your hands, say your question, and I'll repeat the question into the microphone because this is being broadcast on Twitch, which I do every day, and it's my first time. And so for the audio to carry over, I'll need to repeat your questions. So Elizabeth, please come on up.
Thank you. Thank you so much, Jason, and thank you everyone here for coming today. As Jason mentioned, we're going to do a little bit of an interview, and I have no idea what those questions are going to be. So it will be a surprise for everyone, and maybe even my interviewer. I don't know, right? So what I'm going to do, I'm going to read a little bit from the preface of the book, and then I'll give a 15-minute talk. I've timed it so I hopefully won't go over and you won't get bored. So we'll go ahead and kick that off. So my interest in paleontology, and in particular the search for DNA from ancient and extinct organisms, began over a decade ago as an undergraduate majoring in history and philosophy at North Carolina State University. As part of my studies, I was required to take a science elective. I chose the course Dinosaurian World because, like many other students, I thought it would be a walk in the park. Dr. Mary Schweitzer taught the course, which was anything but easy. But I loved it. I spent the next several years digging up dinosaurs in the Badlands of Montana, prepping fossils in the lab, and taking a number of other classes on dinosaur anatomy, physiology, and evolution. After class one day, I asked Dr. Schweitzer a question. I had seen on television that one of the major science channels was airing an upcoming episode on a scientist who had discovered evidence of ancient proteins from a dinosaur. I was planning on watching it, but I wanted to know if she knew of this work, and if so, what she thought of it. Ancient dinosaur proteins? Really? She smiled and said to watch it first, and we could talk about it later. So I did, and I was mortified when I realized that Dr. Mary Schweitzer was the star of the show. She was the scientist suggesting she had extracted evidence of ancient proteins from a 60-million-year-old Tyrannosaurus rex. Dr. Schweitzer's findings, published across top-tier academic journals from Science to Nature, which apparently I had not read, were nothing short of extraordinary. As such, they were quickly and frequently followed by media attention and public speculation. As I learned more about this work, I learned that she was criticized just as much, if not more, than she was celebrated for these pioneering efforts in molecular paleontology. Since the early 1990s, she had been investigating the limits of molecular preservation in fossils as a student studying with Jack Horner, a maverick dinosaur paleontologist and scientific consultant on Steven Spielberg's cinematic production of Michael Crichton's Jurassic Park. Over the years, she had acquired loyal supporters as well as vehement skeptics who resisted the idea that molecules, whether proteins or DNA, could survive intact for millions of years. My exposure to this paleontological controversy and the very public nature of it is what inspired this book. Consequently, the book is a historical examination of the search for molecules from fossils, specifically the search for DNA from fossils, as it progressed from an idea of science fiction into a research reality from the early 1980s to today. In these pages, I explore the controversy and celebrity that not only followed it, but actually came to direct and define, in quite remarkable ways, the formation of a new scientific field, now widely known by both the scientific community and the broader public as the field of ancient DNA research. So, first things first, I'm also going to read from notes because I didn't have time to memorize them. What is ancient DNA research? So for this book, I describe ancient DNA research as the practice of extracting, sequencing, and analyzing DNA from long-dead organisms that are hundreds to maybe hundreds of thousands and even millions of years old. Ancient DNA can be recovered from plants and animals and humans and bacteria, and it can be preserved in skins, tissue, and even bone if it's not a fully mineralized fossil. Now, ancient DNA is really tricky because over time, DNA degrades and it becomes damaged. It's really unlikely to preserve, and it's even harder to extract and sequence properly to make sense of it. It also becomes easily contaminated from exposure to other DNA from the environment or from humans, like scientists touching the specimens. This could generate inaccurate results, and this is important to remember, and we'll come back to it later. But before we do, let me show you some of the iconic specimens from which scientists have tried to, some successfully, some not so successfully, extract DNA from, just to give you a little bit more context. This is the quagga, which went extinct about 150 years ago. This is the thylacine, went extinct about 100 years ago. DNA has also been extracted from mammoths, and this is an example of a frozen baby mammoth from Siberia. And Neanderthals, our ancient ancestors. And of course, insects in amber, just like in Jurassic Park. Now, remember, I'm not a scientist, I'm a historian of science. In other words, I study the people who study the fossils. And it's my job as a historian to take you behind the scenes of science, to show you how it happens, who gets to do it, what gets discovered, and why that matters. So in this book, what I did is I interviewed over 50 scientists from over a dozen countries, primarily in North America and Europe. And what I did is I used their memories of the history to help write a history of how the field of ancient DNA came to be. In doing so, what I found is that public interest played a key role in the development of this discipline, and in particular, the public's interest in using ancient DNA to resurrect extinct organisms, be it from dinosaurs or mammoths. In fact, over the decades, ancient DNA research has grown into much more than a public-facing science. In this book, I argue that it's actually grown into what I call a celebrity science. So what is that? Well, I suggest that a celebrity science is a subjective science that exists and evolves under intense public interest and extreme media exposure. While the media presents scientists working in and around the field with opportunities for publicity, it's important that scientists are also pragmatic in fashioning their own opportunities for public notice. Overall, I argue that a celebrity science is both a process and a product of consistent science-media interactions around a subject of science over a prolonged period of time. And there are a number of instances of this interplay between science and the media, but the most illustrative example is none other than Jurassic Park. So following Michael Crichton's 1990 publication of Jurassic Park, two research teams in the US, one in California and the other in New York, set out to race to extract and sequence multi-million-year-old DNA from insects in amber. In 1993, one of these teams claimed to have recovered DNA from a 135 million-year-old amber-encased weevil. They announced it as the oldest DNA discovered. Nature published the paper on June 10, 1993, and that's important because it was the day after the Jurassic Park movie premiere and one day before its release in theaters across the United States. Media outlets, as well as researchers, took notice of the timing. One scientist that I interviewed made some pretty disparaging remarks about it all. I thought it absolutely extraordinary that a scientific journal, there was no way it was a coincidence, that a prestigious scientific journal like Nature would hold on to an article to wait for the opening day of a movie. Of course, it caused a huge media splash. However, given that Nature was and is a popular and commercial journal, in addition to a scientific one, it's really not unreasonable nor unexpected that the journal would take advantage of an opportunity. But what I want to point out is that what's interesting is the interviewee's perception of the timing, which reflects this general feeling that some scientists view popular outward influences on science as potentially damaging to the integrity of the science within. And this is a tension that is threaded throughout the book, and that researchers working within the celebrity science of ancient DNA research have to wrestle with again and again. Jurassic Park also played a significant role in setting research agendas and influencing professional recruitment. In the mid to late 1990s, for example, a research team at the Natural History Museum in London set out to test the validity of a series of studies claiming to be able to extract multi-million-year-old DNA from amber. One of my interviewees said this: "My job was all down to Jurassic Park. The museum would have never gotten the funding to try and do this DNA from amber if it hadn't been for Jurassic Park in the first place. Part of my entry into the ancient DNA world was all due to a movie, a fanciful, fictional movie." In the end, however, researchers actually debunked this Jurassic Park hypothesis, explaining that they had failed in every instance to recover DNA from really ancient amber fossils. This finding, along with a host of other studies challenging the recovery of really old DNA, led to a dramatic drop in public and professional confidence in the field's credibility. So over the next several years and even decades, scientists found they had to respond to two types of contamination. First, they were responding to contamination as a literal problem, which refers to the potential exposure of other DNA from the environment, bacteria, and even humans to the ancient sample. But they were also They were also responding to contamination in the figurative sense. Contamination here referred to what some viewed as disproportionate media attention or undeserved media attention surrounding the field that could have adverse effects on credibility. This was especially important at a time when the stakes were extremely high for this young field. However, the field's relationship with celebrity was and still is complicated. And just as media attention was perceived to challenge the young field, it actually empowered it too. First, celebrity influenced the community's initial formation. Jurassic Park and the franchise that followed provided momentum behind the emerging practice. And in a way, celebrity was a survival strategy for scientists at a time when success was not necessarily a given. The preservation and extraction of DNA from fossils had to be demonstrated, and obtaining press and public and institutional support was important in doing so. Second, celebrity played a role in ancient DNA research's overall identity as a scientific discipline. Ancient DNA effectively became a brand, and under this new name, the corresponding conferences, newsletters, publications, headlines, and grants gave meaning to what was at first a far-fetched idea. But it's important to note that branding was far from superficial. It was really purposeful and it was pragmatic, and in some cases even necessary. So what's the take-home message from the whole book? Although you should still read it, even though I'm telling you right now. I've only highlighted just a few examples, but this book shows that throughout the history of ancient DNA research, media influence was not limited to just a single time, place, event, issue, or individual. Rather, the media's influence was ongoing, and to the point that the entirety of the discipline's development from the 1980s even to today was shaped and continues to be shaped by it. So given this history outlined in this particular book, celebrity is likely to be a part of the field's future, especially as this science-media connection continues to develop into a more powerful and pervasive phenomenon in the 21st century. Thank you so much for your attention.
Great. That was fantastic. So what we're going to do now, I'm not supposed to move my head too much. I have a tendency to wander, is we're going to ask her some questions and find out a little bit more about Elizabeth's trajectory. Some of the questions are predictable and some might be ones you're not expecting.
I'm
Just
excited.
a little bit of mystery. So, I loved hearing the time in Dr. Schweitzer's class and realizing, this is going to be harder than I thought. But I was wondering if you could just talk a little bit more, we have undergraduates here in the audience as well, about that trajectory from NC State to writing a book, the twists and turns, unexpected moments, doors that open that you walk through. Anything like that would be really delightful to hear about.
Yeah, really good question. Raise your hand if you are an undergrad in this room. Awesome. Raise your hand if you wish you were an undergrad in this room. Me too. Well, that's the short answer is that this was not a planned path. And my parents are here, and they'll tell you that I wanted to be a backup singer for Michael Bolton.
Totally.
Yeah. I can't sing at all, and it took me a long time to figure it out. So I came to State as a history major, and I majored in history because I had a really phenomenal high school teacher. I liked European history, and I liked memorizing dates and information, which I found out when I got here, and I met the Will Kimler over here in the history department, that's not what history really is. History is telling multiple stories about the same thing or different things, because the more stories we have, the better view of history we have. We can't just leave it up to tell it one time and be done with it. So I was a history major and then found out about history of science through Will Kemmler and then also through Bob Brinkman here, who works at the Science Museum. And between meeting them and then Mary and dinosaur paleontology, I found that you could combine them together. And at the time, there wasn't the science and technology studies program. So you really had to carve your way into a little niche that wasn't there. So hopefully that path is easier now. Another thing, I'd never wanted to write the book, ever. I remember sitting in sophomore seminar in history and learning about the book writing process and citations and sources, and remember thinking, it kind of made me sick to my stomach to think about it, you know? Like, ugh, who could or would want to do that? And, you know, how could you have so much to say that you could put it in a book and someone would want to read it? So the reason why this came to be is because when I got into the project, I found that it was too good not to write a book. I mean, that doesn't mean that the book is amazing, but like the material was too good not to do something with it like that. And that's how it came to be.
Great. That's fantastic. So thinking back again to that undergraduate time, what advice would you give your undergraduate self, not necessarily general undergraduates, about this whole path and this trajectory? What do you know professionally or intellectually at this point that you didn't know then, that you would tell yourself?
Well, I'm kind of laughing because my old roommate is here. She's probably thinking there's lots of things we should have told ourselves. That really is a tough one. Thinking back on all the different classes, I mean, being an undergrad is extremely difficult. I think I underestimated. I did well, but it's hard to juggle mentally and emotionally and intellectually probably 6 different subjects. That are completely new to you, and to do it again and again for 4 years straight. And it's really hard to absorb and to fully appreciate all that information. So my best advice would be find at least one thing, a couple things, and hang on to those, because it's hard for it's probably actually impossible to really do it all justice. But pick a few things and don't get to the end of it and wish that you had applied yourself somewhere along the way.
Great,
Yeah.
fantastic. Jason has a follow-up.
Yeah, so in STS, we often, I don't think my mic is on.
Is your mic on?
It is, okay. In STS, we often find that scientists or engineers come to our field because they have some experience with the humanities or social sciences that makes a light go off, and they kind of migrate from the hard sciences, quote unquote, to STS. I just wonder, in your experience of doing paleontology, did you ever think about crossing over and becoming a scientist? I mean, you're enacting dinosaur science, what every kid dreams of, and presumably that future was open for you, given that you had such a close relationship with Dr. Schweitzer. Did you ever consider moving from history to paleontology?
No, not seriously. I liked being the person who was studying the people who were doing the science. And I got I got the best of both worlds. And I think why I couldn't ever really leave history, and also why I got more into sociology of science and philosophy of science, is the thing that I've realized now is that I'm attracted to that, wherever the tension is in an issue or an event, that's what attracts me to it. And so figuring out where's the controversy and what can that controversy tell us about the process of science more broadly, and then also society. Because science, as many of us already know, is not separate from society, and it's a part of it, and the more we can understand that, the more we can improve science and society as a whole. So I never wanted to get away from understanding the controversy. And if I got into the science as a scientist, I would just be a part of the controversy. And it would be really difficult to stand back and see what's going on from a different view.
That's fascinating.
I hadn't really thought about that, though. Yeah, I didn't make the move.
So I hear this, and this kind of relates a little bit to what you're saying right here. I hear from scientists a lot, my research isn't something the publics would be interested in. And I was wondering if you could, considering that we are in a society, and talk a little bit about what you would say to that scientist.
So it is true that, well, I think I'm thinking of some really great quotes that some of my researchers gave me who do ancient DNA, but on the plants, the poor plants. No one wants to read about the plants, and they benefit from the celebrityness of ancient DNA, even if they're doing the plants. But there's still a hierarchy of publicity within ancient DNA. Because they're the dinosaur people, they're the mammoth people, they're the human evolution people. And but people in ancient DNA research, I think, are great examples of scientists who are really savvy at taking even the really uninteresting parts, uninteresting from a public perspective, and making them interesting. And that's not the first time scientists have done it throughout history, but it's on public display more often now. And so ancient DNA research is just but one example, a very good one of how that gets done. I do think that something interesting is in writing this book, but also that was extremely annoying, is trying to really figure out who the public is. So I write through it, the public this, the public that, but who is the public? How do we know that they really like dinosaurs? It just kind of is. And I think what some of the scientists in ancient DNA research were grappling with was, there's the narrative that's set, which is that, can we resurrect a dinosaur? That's the thing that people want to know. But also, can we change that narrative? Can we make what's interesting to the scientists, but also a little bit uninteresting to the public, and put that front and center? So I would say that to the scientist who works on plants, do you work on plants?
No.
Okay.
No,
Does anyone work on plants in here? Oh, you do? Okay. Although I like plants. But I would say that part of being, if you want to try to change what the public perception is of science, is get really creative about how you present your work, because that's where it starts.
Great. Did you have anything? So I just want to shift gears. I don't have any concept of time right now. I should.
It's midnight.
It's midnight. I knew it.
You're fine.
Okay.
It's 5.
All right. I'm fine.
Yeah, it's 5 o'clock.
Oh, it's 5.
Yeah, we have
Oh.
till 5:30. We're fine.
Oh, okay. Yeah. I'm sorry.
I'll
See,
watch
again,
the time.
But we
he's
also
my
have ice
timekeeper.
cream, don't we?
I know.
We do, yes.
That's the best.
So, okay, well, maybe we don't need to shift, but maybe we'll come back to this a little bit. But I do want to ask you about your writing process. And I know a lot of you think about the writing process. And
It's horrible. Don't
many
do
of us
it.
struggle with it, right? So both in finding the time, right? Students?
There's no time.
There's no time. And finding our voice. And can you just talk a little bit more about your writing process, how it might shift when writing for a journal or a short sort of blog type thing compared to a book, a large book with lots of pages? Yeah. What's your process? Sorry.
Yeah, my process is so this is a good question for this particular book, because it started off as a master's thesis, and I'm not being very positive to myself, but it wasn't a very good one now that I think about it. But you do the work the best you can with what you have at the time. And then you find the bits and pieces that are really still interesting, and you grab onto that. And hopefully other people find them interesting too. But that's the only way you can get through to the book part, or to the journal part, or to the blog post part. Is that I think I struggled a lot thinking that I should think other things were really interesting. Or I wish, and I still do that, I still wish that I could grab onto lots of different things and write about them. But find a few things that you feel pretty passionate about, and that's where you can at least start. And writing for a journal, and writing for a book, and writing for a blog, you have to do two things. The first one is really wrap your head around the audience in each one. Think about who is going to read this, and why should they read it. If they only read one thing this whole year, and it's this, why should it be this? Now, it won't be like that for every journal that you write for, because it's a scholarly work, so you have a specific and smaller audience. But that's a good driver for at least getting your start and giving yourself your why.
Yeah, great. So identifying your audience is what you would say is kind of key, and finding the parts that are really interesting and compelling. Yeah. Did you have to follow up?
I just am curious too about, as you write something through many revisions, what sort of feedback did you get through the editing process? How did this project morph from a master's thesis to a book that would be published? It's a real book. I mean, you must be incredibly proud to go from something that was an assignment for a degree program to something that now is for sale in real bookstores.
Yeah, that's pretty incredible when you put it like that. Yeah, so the big paper writing process started here at State, where I wrote the honors thesis in history with Will, and then my husband self-published it. I mean, no one else has bought it except for just him, and he gave it to me as a gift. And this was 12 years ago, and it was the best gift I got because it was really cool to see it like in book form. And then so what I did is, actually I didn't keep that project. I went on to specialize in molecular paleontology. And when I went and did my master's, I worked with a dinosaur paleontologist, and he said, well, why don't you do ancient DNA? Because those guys in that field are crazy. And I said, all right, well, we'll check that out. So it's a small enough subset, and they're interesting people, interesting work. And so I wrote just kind of a landscape of the field from 1980s to maybe 2005, right before a new technology hit. And I stopped it there. And then I was thinking, well, these people are still alive, and as a historian of contemporary science, the great thing is that the people are still alive and I can go talk to them. But the bad thing is that they can read what I write because they're still alive. So I decided to pursue that project as a PhD, but go talk to the people who do the work and use oral history interviews. And that really gave that project. That was what made it, I think, because if you're not talking to the scientists who are doing the work, it's hard to give an accurate representation of who they are, not just as scientists, but as people who are really weird and really fun and really brilliant.
Awesome. So thinking about this, traveling around and meeting these people, I was wondering if you could tell an anecdote or a story about some meeting with one of these ancient DNA characters in your book, and something that happened that was surprising or maybe alarming, anything. Just she looked over there. Are they over there? Yeah, something that came, or maybe they didn't even enter the book because it was so alarming. I don't, There was a few of those.
Yeah. So one thing we got to, because when I was in London doing this, we got to actually travel to a bunch of different countries and do some sightseeing, but also go to the labs at the time. I think one of the really funny moments was I was in, so all the interviews are anonymous because these researchers are working today. But the interviewees like to go through and try to figure out who's who. Sometimes they get it right, but I don't say anything. But most of the time they get it wrong, which is really funny because they'll often quote they'll say, oh, that was me. And really it was someone that they don't like at all. So, and I think that's just incredible because it really, is kind of speaks to the strength of their experiences, that they're actually more shared across the sciences, even despite their differences or their perceived differences. But one thing I really liked, I was at a really prominent lab. I was super nervous, and it took me forever to get into the door. Like I was sending emails, can I come? And finally, we just fly to Germany and show up, and it was a great visit. And when I left at the end of one of the interviews, they're all about like 2 or 3 hours long because scientists do like to talk a lot. And this interviewee said, oh, that was like a therapy session. And I thought, wow, I guess so, because they're talking about how they got into this field and a lot of reflecting on how they do their work that they hadn't really thought about. And I guess that was a compliment.
Yeah, that's awesome.
So I'll put on my STS hat a little bit and ask you this question. Can you make the arguments that the celebrity status of ancient DNA science both makes the science better and at times makes it worse? And what's your evidence for those claims? Because I'm guessing that you could make both statements.
Yeah, and I'm gonna go into some neutral territory and say that I'm not going to say it makes it better or worse, but I'm going to rely on that it's scientists' perception that the celebrity science nature of it can make the research. There can be good or bad consequences, or perhaps like more questionable consequences. So there's definitely that argument to be made, but in the book I try to be really clear and say that celebrity science, in my view, is a positive phenomenon. So I do break my neutrality there, because what I think that despite that tension between the good and the bad consequences, that celebrity science really is, it's science in the late 20th and 21st century. And it's scientists using all of their available resources and using them in really interesting and very practical and beneficial ways. So I think even despite those ups and downs with the hype and the crash and burn nature of some things, that overall it's still a positive phenomenon, and it really shows the scientists they're not passive actors. They're actively constructing this. Sometimes they know it, sometimes they don't.
So, as you traveled around, and just getting back, because I love hearing about these interviews, sorry, refocusing back on the interview. Were there any interviews that you did, I'm sure not all of them made it into the book? And were there a few that didn't make it into the book? And can you just maybe tell us a little bit about why it didn't quite fit with your overarching theme?
So I did include at least one quote from every person, because I wanted everyone to be represented somewhere.
Oh, okay, well then this question doesn't make
No.
sense.
There's a lot of material that I didn't include because this was the hard part that I didn't expect, but having to figure out what was material that was appropriate for a historian of science to include in a book, what was material that was gossip, but that was okay to still put in the book, and what was maybe scandal that was off the record that I probably shouldn't have been privy to.
Yeah.
And so, definitely don't put that in the book. I'm also a young scholar, so I'm trying to keep a job. So that was really hard to look into it and figure out those bits and pieces. But let's see, what was the second part of that question?
It was actually just kind of along those lines. Was there scandal that you couldn't really put in there? Sort of, it's a contentious field. There's probably things that were said that you couldn't put in there. And I guess my question is a little bit reflective of where you are in your trajectory, right? So this is your first book. Maybe as you age, not age, but age on, and you write more books, do you think you could take more liberties with what you could include versus where I'm starting out, I don't want to, I want to be able to make more interviews and get more people excited about how I'm doing this. I just was curious if you could talk about that.
Yeah, very good question. Well, my husband will probably say another book. What? No. And I kind of want to say that too right now. But yeah, I mean, you could rewrite this in 10 years and 20 years. And for those, if you're not really familiar with ancient DNA research, it also goes by paleogenomics, paleogenetics, paleomolecular, there are like 10 different words for it. It's a fast-moving field. It's a high-stakes field. It's an expensive field, and it's cutting-edge technology. And so think about the Neanderthal genome. There's the mammoth genome. There's CRISPR technology and all about de-extinction. Can we bring back the passenger pigeon, the mammoth? There's so much going on, and it's going so quickly. But yeah, really in the long view, in 30 years, it would be really cool to interview some of these researchers again and rewrite some of this with where it's gone for now.
Yeah. Do you see yourself potentially looking at this, not necessarily with ancient DNA, but maybe another topic that has this type of contention and this celebrity attention? That might be a future project for you, not necessarily a book. We don't want to freak anybody out, but do you see, can you think about that? Because you like that tension, right? That's the part that's intriguing you and that you're writing about. And I'm just curious if you have any other ideas of another.
So commercial fossil collection. So the buying and selling of fossils. And if any of you don't know, the North Carolina Museum of Natural Sciences has an incredible specimen, the dueling dinosaurs, that was purchased for a lot of money. And Paul Brinkman here actually worked. You worked on Sue, right? Sue the T-Rex in Chicago, and that was one of the biggest legal and media and political battles all throughout the 1990s. So I'd really like to take a look at that dynamic between, what is a fossil worth and who owns it? Who gets to own it? Private collectors or museums? Is it really in the public good? All of those kinds of questions, because there's a lot of money moving around and there's a lot of toes being stepped on. And not going to try to be a bringer of the peace, but at least a shower of this is where people are coming down on the issue, because you can't figure out where you're crossing a line unless you figure out what those lines are.
Oh, that's great.
So,
but no black market of fossils. That would be dangerous, probably.
So speaking of a lot of money moving around and the mammoths, recent news was that I believe the company Colossal was founded with a huge amount of money to move forward on a mammoth de-extinction project. And so, we've discussed that in my STS class in the Genetic Engineering and Society Center. What perspective do you bring as someone who's studied this field of ancient DNA when you see a news announcement like that? How do you think about how mammoth de-extinction is progressing, what kind of promises are being made, how it fits into the further celebritization of this science?
Yeah, the second, or maybe the last chapter in the book is dedicated to this de-extinction idea, because almost all of my interviewees have been asked, can we bring back a mammoth? Can we bring back a dinosaur? And the funny thing is that none of them really, maybe except for 5 of them, are involved in that research. But it's what they get asked about all the time. And so that chapter explores the question, why? So what's that connection? And it's really what one of the interviewees called it the Jurassic Park effect, and that really close cultural tie that has been there since, probably the 80s with these ideas about, can we bring back the past? And then really popularized by Jurassic Park. But I think what I learned in my interviews is that there are a lot of different scientists with different proximity to de-extinction efforts, and those who are really knowledgeable about the technology actually are a little bit more, they're cautiously optimistic about what can be done. And I would always put a plug for Beth Shapiro and her work, because she's one of those scientists in ancient DNA who I did interview, who really walks that line between popular science and pushing the limits, and also what I will say, rigorous science, and being knowing when to be conservative. And so her book, How to Clone a Mammoth, is a great example of that. But then you also have other, some scientists who are extremely opposed to de-extinction. And it's really interesting because they cite philosophical and ethical and moral reasons for this. And but these new movements, like with the mammoth de-extinction and the whole Pleistocene Park as well, which is a real place, everyone. It is a real place in northern Siberia, right? Mm-hmm. And where they're trying to bring back the tundra ecosystem. And so not just bringing back a mammoth to bring it back, but to help bring back that ecosystem. I think it's not hand waving anymore, because the technology is really fascinating, but also, spoiler alert, ancient DNA probably isn't going to be the way to get us there. It's the gene editing and so many other things that you probably know more about that will get us there. Ancient DNA is just, what Michael Crichton put in the minds of the public, and it's there to stay.
That's great. So I think we have time for one more question. And we talked about sort of talking to your undergraduate self, but we have mentors in the audience as well. And so I thought maybe you could talk a little bit about some of your mentors along the way, and maybe what made their mentoring meaningful. I'm putting you on the spot. No.
Yeah, and this is some advice too for undergrads and grad students, and actually just any person at any point in their life. Find someone who's really interesting and who's nice. That can be hard. Find someone who's really interesting and who's nice, and lean on them. I probably ask, well, I don't know. It's pretty quiet in class, but anytime I wanted to do anything else, I always asked probably way too many questions. My PhD supervisor called me, I think annoyingly persistent or something, but in a nice way. We're friends.
Yeah.
But, I was always right there, But so mentors along the way, definitely will, because I took that class with Mary, and I got into the honors history program, and you made those connections, I think, for me. Like, oh, yeah, you probably laughed that I was taking her class and thought it would be easy. But you made those connections for me. So I think if people make connections for you, take them seriously. Mm-hmm. You don't have to do them, but just take them seriously. And then I met Paul. Can I tell your story? You were in the basement of the museum. He was in a dingy office, the basement of the Science Museum. And you were writing your book. And you might have been a little bit miserable at the time. But I thought, I want to do that. And now he's at a big old nice office at the Science Museum with windows, a good view. And, you know, he was a great example of a path. And also, he was just a nice person with good ideas. And Mary was instrumental, too. She was all for getting more women and just other people in science. And so she pushed me along a lot of the ways. I ended up taking some classes I probably shouldn't have taken because they were really hard. And then Will pointed me to someone Michael Roos, an inappropriate British man. But he is the one who really made this, I think, push me along this book path and made it happen. So when people say, hey, you should think about this, or hey, you should talk to them, at least think about doing it, because those are the people that kind of like set up the ladder for you. Otherwise I'd just be walking around. I don't know.
Yeah.
I don't know what I would be doing. Not singing for Michael Bolton.
I don't know. This has been so great to get to know you a little bit more, Elizabeth. I definitely want to open it up to the audience. We'll repeat your question because what are we twitching right now? And I'll repeat the question and then you can answer it. But thank you so much. I really enjoyed talking to you.
Well, thank you.
So we probably just have time for 2 questions from the audience, and then also Elizabeth has generously offered to hang around afterwards to talk informally with you. But does anyone like to offer a question? Yes, please.
I'm an STS major, so I was wondering if you have hopes for the field of STS moving forward, and do you express those hopes through the book or in history of science, that type of humanities incorporation?
So the question was, do you have hopes for the field of STS, being an STS scholar, and how do you express those hopes, either in the book or in other ways?
Wow, that's a dinger of a question. Let's see. So I do want to say I was new to STS during my PhD. So I think, I was born and raised in a history of science, philosophy of science kind of world. And that, I don't really know exactly how it's different than science and technology studies. I don't think anyone really does. But it took a little bit for me to wrap my head around just the different stuff you could do. And I think, actually, yeah, my hope for this field of science and technologies is that it would, I think, as a historian of science, it was a bit unusual to incorporate sociology of science methods with my work. And I think some people were a little bit skeptical of that. But I think that whatever arbitrary boundaries there are between whatever you do in STS, I would say recognize the boundaries, but go over them if you want to, because that's where good stuff gets done, I think. And then do I make that, what do I advocate for in the book? I think maybe it was just that, and maybe I didn't do it, maybe I didn't say it as intentionally. So if I rewrite this book, I'll put that in there. So thank you, good question.
That is the sign of a good question, to cause a rewrite of the book. One more question from the audience? Yes, sir.
How do you think scientists are pressured to publish certain results just to continue their funding? And how do you think that may obscure scientific facts?
So the question is about the pressure on scientists to publish and write grants, and how that might influence their science in negative ways in terms of the knowledge that they produce. Okay.
Yeah, so one of my interviewees called it a self-perpetuating system. So you have to do a certain type of work to get a certain type of results, meaning rigorous scientific work that also has that public element, that public interest element. In order to get it in a certain type of journal that gets certain type of media attention, that will then get a certain type of funding to fund your lab and your researchers and your students who you are raising. And it's a cycle. And this isn't unique to ancient DNA research, and other people have shown this before too. But what you see in the book is that you really see that self-perpetuating system in action, and in lots of different ways. So I wouldn't go so far to say that poor research comes out of that model, and I wouldn't go to say that, bad research comes out of it. I think the more we can be cognizant of what some of the drivers are behind the questions that get asked, the research that gets funded, where it gets published, who gets to do it. If you don't understand the system, that's where I think it gets messy and mistakes can get made. But understanding how it works, you can try to mitigate those. And then maybe this is more just a story of capitalism, but I'm not writing that one. That's a really good question. Thank you so much.
Yeah.
Well, thank you to the audience members for attending today. Thank you to Elizabeth for sharing your work. Thank you to Martha for helping to interview. Thanks to the NC State Libraries for hosting us. And thanks to the STS program that is providing chocolate ice cream at the back of the room for you right now.
Thank you.
Actually, I said it's chocolate. I don't know. That may be wishful thinking. It's my own bias.
There's ice cream